So, the burning velocity SL, after determining the KST and Pmax, can be determined by using a simple expression. The deflection index can also be used to estimate the laminar burning velocity for the given dust concentration and particle size. KST divided by 4.84, which is an empirical constant, into P max by P naught. P naught is the initial pressure, P max is the maximum pressure, minus 1 into P max. So, this is the simple correlation used to get a estimation of the laminar burning velocity. Now, smaller vessel, everything remains laminar, I can use this expression. Bigger vessels, initially laminar but transitions to turbulent. Turbulent regime, the burning velocity is St, can be calculated as a function of SL plus the turbulent intensity and the length scale, which is say integral length scale L naught. So, there are correlations for this. So, St as a function of SL, U dot RMS and L naught. This is available. We can use this to estimate St as a function of SL. And we know that as the time increases, transition turbulent occurs, URMS increases, and we can see that it will result in flame acceleration. So, based upon that, St also will increase as the turbulent intensity increases. So, this correlation St as a function of SL, U dot RMS and L naught for turbulent gas air flames are available, but for turbulent dust air flames they are not available, and more research is required for this field. Okay. Some effect of dust concentration on turbulent burning velocity has been discussed by Rockwell and Ranganathan in their PhD thesis. Now, we will go to wildland or forest fires. Basically, this is only an introduction. So, please understand that these are all huge fires, very unwanted fires first of all, but it actually occurs. There are natural causes for this, also man-made causes. Okay, so these fires once initiated becomes very huge in size. The scale, large scale fires are very complicated also. Because of the fact that different vegetations of different characteristics are involved in this. Even green leaves can burn. So, forest fires, we will see the causes. Huge unwarranted fire occurring in a forest or a vegetation land, wild land, is generally called a forest fire. But is it avoidable? No. In the forest ecosystem, this is a natural feature. We can see the reports all over the world that fire in a forest has been occurring almost every year, etc. And they are very huge, they remain for several days, and this is actually naturally occurring in several cases. And due to this, several changes have occurred to the earth because of the destruction of the vegetation, emissions which are emitted, and so on. Several changes in the have occurred. Okay, basically the atmospheric conditions have changed and so on. Further, severe damage has been caused to the vegetation because they are burning, and once for a plant or a tree to grow, it takes several years. Once that is destroyed in a fire, you will see that for the same vegetation to come up, it's not going to be possible very sooner. Similarly, some animals also can get destroyed, and as I told you, the emissions out of this can affect environment to a very severe extent. So, but as I told you, this has been a natural feature in a forest ecosystem. So, in several countries, this forest fire has been occurring, and there is no way to predict this, but there are several research works which can which is actually uh, how to extinguish this fire as soon as possible once it is onset. So research are going on in that direction. Forest fires causes several changes in the features of the earth and water systems. Obviously, when the vegetation itself burns, the soil properties also change. The vegetation accumulation will occur. Genetic features of the plants and its regeneration will change. Wildlife, basically insect, etc., they are very much affected. Okay, so these are reported in Barnes et al. In 1998 in detail how they are affected. The forest fire is caused naturally, or in some cases they are man-made. But natural causes are basically uh, major or natural causes only. So, out of the natural cause, lightning is one of the important cause for onsetting several forest fires. Now, when dry, slender trunks rub over each other, like bamboos, etc., then rolling of rocks, creating hot spot, etc., and sparks, these also can cause the forest fire naturally. So, the main point here is there is a wild land. Wild land is very, very heterogeneous, very complex to understand. In this wild land, there are several types of vegetation, and some natural causes like lightning, rubbing of these trees, rolling of rocks, etc., can cause a forest fire. And a man-made forest fire can be, say, for example, the camp during the camp in the forest, some uh, fire can be initiated, etc. So, but you can see this, the man-made causes are not actually regular, but these natural causes are regular in creating the forest fires. But forest fire is actually totally unwarranted. So, if it's avoided, it's good. But in some cases, the forest fire also, since it's a part of the forest ecosystem, this also has some this like we cannot avoid it also. So now, man-made, as I told you, from basically from forest camps, match taken, cigarette left unburned, burning, then some intended, the intentional burning of vegetation fields. Like for example, paddy straw field after the harvest, it is burnt before cultivating the wheat in say Punjab in India. So this, but actually speaking, this very remote chance to create a forest fire. But if this vegetation field are near a forest area, this can cause a forest fire. But you can see that this man-made can be avoided, but the natural causes we cannot avoid that. It may occur without the uh, sense of the people, okay, who are trying to guard the vegetation. So now the forest fire types are discussed in this slide. Okay, now ground fire. It's taken stock from Adobe stock.adobe.com, gives several pictures of this. The ground fire is like this. Mostly happens in the ground, as the name suggests. The decayed roots and debris in the underground, or the duff layer, what we can say. That is, the vegetation is compact. See, for example, when you have a tree, there will be some vegetation will be compacted vegetation around the tree, which can actually get degraded. So this compacted vegetation can be leaves, barks, or twigs, and you can see that it is burning around the tree itself. So this actually can burn. That causes the ground fire. Okay, so the decayed roots, debris underground, or duff layer. Duff layer basically is the compact vegetation which is there. See, the leaves will fall. Okay, then the twigs, everything will fall near the root itself, and they get compacted. due to rain and other movement of animals and so on. This once get ignited causes the ground fire. Okay. Now how it burns? Basically it burns as a glowing combustion because these are already compacted. Once it get ignited, some initial flames will be there. After that it continues as glowing combustion, that is red hot layer will be seen, produces little smoke and spread very slowly because of the compacted nature. Okay. So very slowly it spreads. Then the second category will be surface fire. The surface fire involve, see, the loose leaves. It is not compacted as in the ground fire case. The loose dry leaves which fall down, the loose leaves and the twigs, needles, twigs etc., needles, then whatever be in the curve, the ground itself, herbs, shrubs etc., or small plants, they can also burn around the surface of the ground. Okay. So it is not going to basically go and go to the ground level. So it is going to burn in the ground level itself. So this is the surface fire. Some flaming combustion will occur based upon the dryness of these loose leaves, needles, herbs, shrubs etc. It will occur as a flaming combustion. And this is the typical, again some example for this. Here you can see that the flaming combustion occurs, and the surface fires, since it is a flaming combustion, because of the fact that, see, when it is in the case of ground fire, it is actually a compacted vegetation. That means the porosity is low. Porosity is low. So what happens is, due to low porosity, a smoldering type of combustion basically occurs after flaming combustion. Predominantly this combustion will be a smoldering type of combustion. So the heat release rate, spread rate etc. are very low. On the other hand, surface fire involve loose leaves, needles etc. The porosity is higher. So the higher porosity, what happens? The air entrainment within the porous spaces will be higher. So a flaming combustion is possible, and in a porous bed, the flame also can spread at a faster rate. The porous bed, correct? So that is the reason why the surface fire can spread at a much faster rate than the ground. Okay. Now the flame height also, you can see that the flame height also will be typically bigger because of the large burning rate. Okay, but there are several factors which will affect this, that is the amount of material available for burning. Okay. If this is higher, then burning rate will also be higher. Then the slope, see, when it is horizontal, the natural convection heat flow will be somewhat restricted. If it is a slope, then you can see that the burning rate will be higher slope. Similarly, in a forced convection, if there is a wind, then that also can induce oxygen availability. If the wind is too strong, it may also affect the burning and so on. So material availability, that is how much stock is available for burning, then the slope of the ground, then the wind direction and the magnitude of the wind velocity will also affect the spread rate. Obviously, when there is some rain etc., moisture, this, as I told you, their loose leaves, needles, herbs, shrubs, small plants etc., if they are dry, they will burn at a faster rate. If there is some rain and moisture content is higher in this, then you can see that the burning rate will be affected and the spread rate also will be affected. Okay. So the surface fires are basically due to the fallen leaves, loosely packed combustible material, vegetation, which will cause that. So the surface fires are also affected by the height of the material and the density. Okay. So obviously, how they are packed, how, so if density is high, that means they are, for example, where we are talking about a leaf or a needle, shrubs, etc., which are actually light in this and they are packed in the ground. If you have some trunk or big branches fallen down, then they will not burn at the same rate as the leaves and needles, etc. So, how fast the material, individual material can burn, that will contribute to the faster spread of the surface fire. Then the third category is the crown fire. So, this is the website nrcan.gc.ca. You can get some pictures on the here. Basically, surface fire like this causes the ignition of the entire tree. What happens is the crown fire is often caused by a surface fire. The fire basically is seen in the top part of the trees, all the branches, tall shrubs, etc., well above the surface because of the radiative ignition, etc. See, for example, if this fire height is higher, it may ignite the branches of the trees. That branches of the trees again will ignite. So, the crown, the top portion of the trees will get ignited due to typically a surface fire. A ground fire will not have so much heat release to cause a crown fire, but surface fire, which are very many flaming in nature, that will actually cause ignition of the branches, tall shrubs, etc., and cause a ground fire, crown fire. This crown fire basically occurs in the top portion, or we can say the entire tree will be burning. So now it burns individual trees or maybe trees which are very close to each other, forming a small group, that also will be burnt, and it spreads from one tree to other tree. Okay, so when there is, say, like for example, if there is slender tree trunks which are closely neighbored with each other, then once the surface fire forms, the tree group can burn as a one entity. Or if there is a separation distance is more between these trees, then individual trees can burn. So these are the two things. Then it burns individual trees or small group of trees when in passive mode. Passive mode means what? The surface fire has caused this crown fire. This is passive ignition. But active crown fire means it actually spreads from one tree top to the other tree top. It spreads basically. Okay, once based upon the heat release from one of the crown and the separation distance between the other tree, etc., it spreads between these two trees. So that is the second level of this. So now in this case, based upon the dryness of these trees, amount of branches, shrubs, etc., present in the tree, in the top portion of the tree, the burning rate will be severe and it can burn several trees at a time. So now we will go into after effects of the forest trees. So basically in forests from West Bengal, several fires have occurred. So Directorate of Forests in West Bengal has released a document called Forest Protection, in which they have told about some consequences of the forest fires. First one is damage to the plants. Okay, surface fire is going to cause lot of damages. Shrubs, herbs, and small plants are affected because they are going to burn in the surface fire condition. Thin bogs of trees, small leaves are much affected. Now, based on the age of the trees, many species of them are affected in variable manner. See, lot of trees will be more than 50 years old and so on. So, based upon that, we can see that see, for example, the drying of these trees also will be heterogeneous in nature. Because of that, we can see variable manner the burning effects will be present. Several plants and trees are destroyed by active and passive ground. We can also seen that because of the fact that the fire spreads between the crowns of two trees in active mode, or a group of trees itself will be burnt in passive mode, etc. So basically lot of damages will be caused to plants because of the forest fire. Then damage to regeneration. Plants and small plantations are severely affected due to ground and surface fires, because the ground basically affects the nature of the soil itself. Surface fire affects the, as I told in the beginning, shrubs, herbs, small plants, etc. So the in-depth roots are affected, solid, the soil properties are affected, so the possibility of regeneration becomes very, very less. Okay, then soil, effect damage to soil. Soil erosion gets enhanced due to the forest fires. Erosion. Organic material in the soil is also removed. That means you cannot cultivate in the same rate in the same soil. Then soil becomes more compact and non-porous. See, if the solid becomes non-porous, the water cannot seep to it and go to the roots of the trees. So this will affect the cultivation. So these are the important problems. Then we can also say that some damage is caused to wild animals. See, when the crown fires occur, nests, eggs and young birds in the trees are gone. If the fire intensity is higher, then even bigger animals are also affected. So now again the same document, fire forest protection, has given some measures to prevent the forest fires. Okay, there are some regulatory provisions. For example, how the people should behave in a forest, how they should quench the fires in camps, etc. Regulatory provisions are there, because this is out of acts, rules and regulations. And people are also educated, telling about the consequence of the forest fire, etc. So there are few things which we can try to do to prevent the forest fires. First of all, is there any way to forecast the forest fire? Predictions using statistical means. See, forest fire may be seasonal. In some season, it will occur. So, is there any way to statistically analyze that? Based upon the temperature, wind direction, humidity, etc., the forest fire can occur. So, predictions using statistical means on fires can be made by analyzing data of temperature, humidity and wind, and you build some this. So, based upon this, you can predict that the forest fire in some regions can occur based upon the statistics what we develop over the years. Next, how to get this data? We have to use proper instruments, sophisticated instruments to collect this data, and we can analyze that. Then controlled burning. So this is actually voluntarily done. In a forest, small pots and patches of dry grasses, shrubs and dry leaves on grounds, wood twigs, etc. are voluntarily burnt, so that it will not onset the surface fire or ground fire at all. If that occurs, see, if the forest is accessible, then only we can do it, or else it is not possible. This is control burning is possible in some cases where the forests are present near some fields and so on, or it is not possible. Then the third is the fire line. You have a forest area, you know the forest area. Now, the forest area is now divided into many blocks. These blocks can extend to 3 to 5 meter wide barriers, and segregate or discretize this area into several things, and in which the flammable material are intentionally burnt. So, if these lines are avoided, then what happens? The fire will not spread from one barrier to another barrier. So, this is the third where you can use the fire barrier lines to extinguish a forest fire. So now what we can do here is firefighters can move through these and extinguish the fire in identified blocks. But again, it is possible only in a smaller forest or accessible forest, etc. In most cases, it is done. So to prevent basically natural occurring fire, etc., the forecasting with good data of temperature, humidity, and wind is one of the important thing. By that, by seeing the weather, etc., we can say whether forest fire can occur, and the measure to extinguish it as soon as possible can be triggered. Controlled burning is possible in some cases where you go and voluntarily burn the easily flammable components of the vegetation. Forest line is slightly complicated, but it can also be done to prevent the forest fire to spread from one barrier to another barrier and so on. And also these lines will help the firefighters to go through the blocks and extinguish the fire as soon as possible. So these are the things. In the forest fire, basically we have talked about the causes, man-made or natural. Then we have talked about the types, ground, surface and ground fire, and we have talked about what are the after effects and also some preventive measures. Okay, so this is the end of the module.